right now, and in this challenge, the team of Tula State University will challenge the team of Europe Medical University. So, please don't waste time, let's challenge the team.
Last problem, and our opponent is Navation. So we have challenge.
Something that and who will be the reviewer? Who will be the reviewer?
I'll be very sure.
Greetings, dear ladies and gentlemen, and I suggest us to come to our normal technological problems. So here we have a white today is an important problem to figure out waste waters. Usually industrial wastewaters compare 90–95% of water itself and 5–10% of different inorganic and organic substances. They are listed here. So what we need to do around 60,000 liters of wastewater per year. Do it with a budget of $100,000 and make it clear for these parameters. What we have with the traditional methods of cleaning wastewater. So I'd like to say that traditional methods usually clean only organic or inorganic substances. So with inorganic we can fight with a filter system, but it's complex, it costs high, and moreover it doesn't supply us with cleaning of organic substances. And bacteria are usually ineffective in case of inorganic substances. Of course, with such volumes, we can use evaporational systems with decomposing of water vapor with organic substances, but it will energetically cost too much, so we decided to move on to biological methods. So here it is, feature remediation. This is a process when plants absorb inorganic compounds and a lot of organic compounds. What's important, the metals which are absorbed can be regenerated. For example, there is a plant, Cibertia aquitana, which absorbs up to 25% of heavy metals according to its mass. So it's rather high effect. But we, as you can see here, we kind of find solution for amines. And in our wastewaters we have amines and hydrogens. So this method is partly suitable. Next please. What about bacterial degradation? Well, according to new literature, you can see it here, today we have the bacteria found who can comply with hydrogens. Usual bacteria cannot comply with it, but new types can. So these bacteria are capable of fighting with organics and using in their life cycles. So the most logical point to do, we will, next slide please, we will unite these two methods. So what we have? We have the soil. We have plants on it which grow. And bacteria in the soil itself. In this type soil also is drainage systems for water that we pulverized on the top. Next, please. Here you can see the bacteria in soil which can comply with different organic substances. There are links and the bacteria. Next. And here you can see plants and what metals they can absorb and what plants and bacteria can absorb in general. So we see that the problem of taking out the whole substances we have in wastewater seems to be complete. Next, please. What about the technique? So we have a barrel with wastewater. We brought it. The customer brought it to us, or with pipes, or with cargo delivery. It didn't matter. From this barrel, we pulverize the tanks with the soil where grow plants. In case of Russian conditions, we need to do this process the whole year, and so we will make the greenhouses and put the tanks with the plants and put electrical light, which is now used in agriculture for growing plants, tomatoes or so on. And we will do this for 3 times this cycle. So in one greenhouse, then the second, then the third, and then we will analyze it. What about mathematics? Here is all point. Well, we have 60,000 liters per year. For a day, it is 164 liters. Taking into consideration the need of weekends, it will be 200 liters of wastewater per day we need to clean out. Okay, the concentration of toxic agents is rather high for plants, so we dilute this water with water from canalization for approximately 1 to 10. So we have 2,000 liters of visual water mixed with 200 water waste. If we will analyze this in currents, so minutes will have approximately 15 liters per minute we need to pulverize in these tanks so that it will be cleaned down. The tanks we take not one but 6 big tanks around 6 meters in diameter each. With soil, soil is also important. Soil will take lined peat. It consists of peat and calcium carbonate. In processes of decomposition of organic substances, we may have organic acids, and our pH won't be suitable for the task. But calcium carbonate is not soluble in water, but with acids it reacts and makes our medium back to neutral or even more basic. So, we have 15 liters a minute pulverized in these 6 tanks. Later it goes down as a drainage and then by pipes into a pump. Pump makes it to the second barrel, and then the cycle returns to 1, 2, 3, and on the end we have clean water and we analyze it in a laboratory or something else. So, what about the economics? Next slide, please. We've counted all what I mentioned. So, for wastewater treatment, for greenhouses, for electricity, for tanks, we have $37,000 approximately. Waste for pit, for landfill, for land pit, we have approximately $25,000. And according to this, we need to sustain this system. So 1/3 cost will not be so will not cost much because we need only a bit of electricity and water. So here we have $500 or $1,000 per month. So economically, the task is solved. We will not overgrow our budget, and for a year we'll completely clean out these wastewaters. That's all. Thanks for your attention.
Dear opponent, do you have any clarifying questions? Okay, you have 1 minute to prepare.
Clear now?
Okay, the time is over. Please welcome our speaker.
Good evening. My name is Dimitri. I'm from Tulsa State University, and now I'm going to oppose your solution. So, first of all, I'd like to say that your only team who made this problem, it's already impressive. Thank you. And your solution is interesting. Biological approach is very promising now, and your decision, your solution is promising too, I think. But I want to discuss some controversial points. First of all, you didn't say about mechanical treatment, because we have water wastes. They could be full of any garbage, any big particles of inorganic things, and etc. Maybe you should clean it before you will put it in the tank. Next, are you going to prepare your bacteria and plants, because they will work in very difficult conditions, maybe even extreme conditions. Next, how long will be long this process of cleaning? What you didn't mention about time. And next, it will be a biological system in your tank. How are you going to control all parameters of activity of bacteria, plants? For example, if pH changes, all living organisms may die. So, and I think that's enough so far.
Thank you very much. Answer the questions.
For the first question, you mentioned garbage. Well, okay, it's maybe a problem, but see on the screen. The main verb force here is gravitation. So the water pulls down. And we just can set something like cursor, but without force, so that the water will pass and the garbage will do that. Because I said we had the weekends, we will clean out the garbage, and next week it will work fully. About long cleaning conditions. As I mentioned, we dilute water for wastewater for 10 times. So in our wastewater we have 90% of water, and in diluted we will have 99 and even more % of water. So the almost all substances that will be coming for plants and for bacteria, they will be useful. They will need it because we put the only water. Water is useful, but we need substances to grow for these plants and bacteria. And as I mentioned, these plants and bacteria absorb the substances for their life cycles. So, in small concentrations, as I mentioned, it will work to fast enough. So, on controlling, we propose that we take wastewaters from one factory, and as we know, factory work is stable. Usually it is stable, and wastewater consists of approximately the same substances in the same equations. 1-2% or can be derived, but not so big. So when we introduced this, we didn't change the conditions. We didn't change conditions much. That's why there is no reason for bacteria and plants to die. According to my calculations, if we try to clean out 60,000 liters of wastewater, we will have approximately 600-700 kilos of solid waste, which will lay there in soil. If you like, I will. Yes. So 600-700 kilos of solid waste. As I mentioned, our tanks are 6 meters in diameter, and we have 6 of them in one greenhouse. So if you calculate, you'll see that this is very little concentration of solid states that will rest there. So this is also not a problem. And what you asked for the second
Yes, about preparations for bacteria and plants.
Preparations for bacteria and plants. Well, perhaps now I will not tell you about this in detail, but in literature it is known. Processes these plants are known and bacteria are known, so the information there you could find.
I'd like to know, you're going to use the same bacteria and plants for a long time. I mean, again and again. Yes?
I want to mention this. Yes. Sorry. This fence. Of course, this system is a long-year living. It's a long-year living system. But what we have to do after a year of usage, a year or two, we need to change our soil. Perhaps this is all we need to do to maintain the processes. This is about biological ones, so let's go for the next time.
Also, how are you going to control plants and bacteria in your tank? For example, if we get some phosphates, it will make uncontrolled reproduction of bacteria and plants. Our water may be blooming.
I understand the key thing on this. This is the problem for filter remediation when we use the plants without bacteria or bacteria without plants. But they are in symbiosis in this process. And if one of plants have too much substances, bacteria will use them as a recycle, so they help each other to survive. So the system's stability improves by this symbiosis.
Okay, can you detail how bacteria will handle with heavy metals?
try to make an appointment. Bacteria do not help with metals. With metals help plants. As I mentioned earlier, there are types of plants that can absorb up to 25% of their mass in about 25% of the mass for metals, heavy metals. Yes, you can see here what plants, what metals consume. This could be checked out by this link, so I think there is no problem. Even non metals are consumed in selenium and tellurium. So
I think the problem was solved. I think it's time to discuss with somebody else.
Who will make the evaluation of already good evening. Thanks for correcting me. What I should say as a reviewer. The presentation. Well, literature, pages, advantages, disadvantages, all this was on the presentation. That's cool because sometimes we forget this or that, but all of this was in the presentation. They have some asking as Ulf's team already said me how to form my presentation. I would like to ask you in further. You use a lot of numbers, the pH, your calculations about how much we use. It will be really cool if you make one more slide just to show the calculation, because it's like 5:30 and the brain is like already boiling and it's hard, for understanding something. So it'll be really cool. So plus, as I think, can you have the task? Yeah, it will be really cool. There's numbers here. Oh, sorry. There are numbers here. There are requirements, and it will be cool if you. It will be really great if you, in the conclusions, you'll say this we solved, this we applied, this we didn't, for example, do, because really I didn't hear or something, but actually I didn't hear you saying about COD and BOD. So what else should I say? About the speaker, he knew all the information. He made calculation. He really did I suppose he did the task himself. He knows the presentation really good. He can provide calculations in his brain at this time. So it was really cool for him. What about the opening? I assume that you didn't prepare this task at home at all. So it was really cool for you, to ask proper questions about the garbage, about the grooming, about the logical part. That was actually the questions that were needed actually to find out how this solution would work. So, and the position was cool, but I think he missed some points. For example, you said that the plant will absorb organic compounds. Okay, I agree with that, but what about inorganic compounds? For example, if you have a lot of, for example, metal, potassium ions, the thing is that it will destroy your plant because there should be a proper sodium potassium proportion and cells will probably make perfect. Okay? So I'll just finish that. I think that, and the speaker and the especially opponent, it was hard for him, had a good time. They had a good, meaningful polemic. So now I'm here. So I think it was really good at this time, but I think there are more questions for the task for the speaker. Okay.
You mentioned inorganic compounds. As I already said, plants can consume a lot of metal complexes and metals. For the case of will our plants die in bacteria because of lots of waste? As I mentioned too, we dilute the wastewater, which we can use condensation water to just and remind. So if we dilute, we have enough concentration. We choose the optimal one, 1 to 10. Perhaps it may be the right, but it depends on the technique we use. So we dilute water, and the amount of compounds we have becomes optimal to these plants. If you want, I would like to take an example. In our university, there was a big tree, and someone wanted, administration wanted to cut it off, and they decided that our wastes from concentrated acids, bases, and what we have in these big bottles. We just pulled it off on this tree, about 20 kilos, and in the next spring it just like green leaves, etc., etc. So plants like elements because they need them in their life cycle. And here we give it optimal amount of elements so that they can, in symbols of bacteria, live and recuperate, degrade the organics, hydrazines, amines, and so on.
Okay, I agree that microelements are great. Some macroelements are great. Are you sure that all of these metals are good in plants?
Perhaps I would say they are not all good, but they are not a harm. They can just absorb it and all.
Okay, so your plant just absorbs. Okay, what about the oxides? What about? I assume that these are catch-ups or that are metal particles.
Metal complexes.
Metal complexes. Okay.
Because of this,
so
metal complexes.
Okay, so the metal complexes are actually good. Okay, so. And then we have some track.
Same.
Okay. Okay. We find out. I have one more question. For how long? From the moment you start your plant will absorb actually the metals from your water, and what is the capacity actually? So it can't. I suppose it can absorb for infinity.
Yes, sure. So we have our wastes. We put them in the first barrel. Barrels. Next. The barrels, the last one. Okay. We have waste waters, and we have a current of flowing from a barrel this waste. So they move on 3 times through this system, and approximately after 2 days we will have enough pure water that to be analyzed and reused.
Is this research or your calculations?
This is just a comment on slides.
No. Is this, when you say 2 days, is this your calculations or it's literature review?
It's my approximate calculations.
Oh, okay, that's good. Again, a little bit of numbers will be really helpful.
You see, this task is with pointed out numbers. So it suggests that we suggest a decision with the pointed out numbers too. So how it will cost, how much, how long it will work, and so on.
Thank you very much. The polemics is over.
And I have some questions concerning the usage of these plants. First of all, problem, the
plants are pH-dependent. And depending on the pH of your wastewater, to which plants will be used? Because we know that some plants prefer acidified soil, some of them alkaline one.
On this slide you can see the plants we use. Besides, I mentioned that in soil we have calcium carbonate, so it regulates the pH of the system.
Okay. And also, what is the degree of accumulation of these metals and the speed of accumulation? Because that will influence on the territory we should have for the greenhouses.
According to my calculations, these greenhouses will take square 24 meters from 40 meters. In our conditions, especially when lots of factories are nowadays outside of the cities, it is not a problem. About the metals. So, as I mentioned, several plants can absorb up to 25% of the metals. And what about the speed? We dilute the waste, so we have and pulverized it onto 6 tanks, so that metal concentration will be small enough that the speed of absorption by plants will be faster than we add these metals to the system.
But from another point of view, if you decrease the concentration of a metal ions, the speed of the absorption should also decrease significantly.
It's only metals, you say.
The equilibrium. If you have the equilibrium between the metals and the wastewater and the metal in the plant.
The plants consume the metals by the lower side, and because water flows slowly through this, you know this, water flows slowly down, so there will be enough time for plants to consume the metal molecules.
But it seems to me that the degree of accumulation will be not so high if you have low concentration. Okay.
If you want, I will add we can use aeration systems when we put a pipe into the tanks and put the air. This will speed up the process.
Short question. You said to spray the wastewater on the plants, and according to the task, some volatile organic amines and some volatile waste materials. So how you will solve the problem of the air in your greenhouse?
This problem is simply solved because the propulsion system I use just for example. Today, almost in all countries that are highly in Israel, for example, use the system of watering, not with polarizing, but with controllable adding small amounts of water for time. It's just made by thin holes in the pipes. So this helps with two things. First of all, our plants are not now endangered of aggressive substances, so their leaves are not damaged, and we bring water right into the soil. And in air we have no aerosol or something like that with dangerous substances.
Thank you very much. Thank you all. So, now we will announce the scores. The first score for the speakers team for the solution is 6, 5, 5, 8, 7, 6, 7, 8, 5, 5, 9, 8, 5, 7. Once again, please. 6, 5, 5, 8, 7, 6, 7, 8, 5, 5, 9, 8, 5, 7. Thank you very much. The second score for the speakers team for the presentation is 8, 8, 6, 8, 8, 6, 9, 8, 7, 5, 9, 8, 7, 9. Once again, 8, 8, 6, 8, 8, 6, 9, 8, 7, 5, 9, 8, 7, 9. Thank you very much. And this third score for the position is 7, 7, 6, 6, 7, 5, 5, 7, 6, 5, 9, 8, 7, 8. Once again, 7, 7, 6, 6, 7, 5, 5, 7, 6, 5, 9, 8, 7, 8. Thank you very much. I think we covered them. And the last challenge